Hello, this is Clayton Balmus, and I'm your teacher today here in our audio classroom here at SynMax University, available at synmaxperformancelubricants.com. And today I'm just going to quickly go through what's called oil analysis basics. How an oil analysis reports will show wear metals, oil, water, fuel patterns, or information so you can improve your engine maintenance, performance, or product comparison. Now, the data that we have here is for information purposes only. We're not comparing any products to anybody. In fact, some of the data in here is a few years old, so this is totally neutral and it's only for information. All right. So let's. I hope you enjoy listening to this as much as I enjoy sharing it with you. Now, all oil analysis reports have the same basic elements. You have your oil information. It's going to share about wear metals and parts per million, your copper, your lead, aluminum, whatever. The additive measurement. Now this is really what shows you what's in the oil. Your how much moly, your ZDDP, uh, zinc dilithium magnesium, calcium, the contaminants that's getting into the fuel. Now this is very important. We're going to get into where sometimes dirt will affect your anti-foam package. And then it'll really tell you the truth of your oil properties, which is your viscosity and other elements that are in there. Now there's a lot of additives which a lot of manufacturers blend into the oil in different forms and quantities. Um, for instance, at SynMax, we've got some variety of diamond-like carbonates that we're able to use in our aerospace-based oils. But a lot of times, the products you're going to see is like molybdenum or moly, zinc, uh, which is like your buffer zone. That's your ZDDP. There's zinc and phosphorus together. Magnesium is a detergent, which helps remove and hold and suspend dirt, along with calcium, sodium, and you've got many elements in there. Now, for instance, here's an oil sample analysis, and it was Valvoline Racing, a 10W30 racing oil, synthetic, and a Joe Gibbs 10W30 racing oil, both from about 5 years ago. And you can see just because it says racing on the outside, it really doesn't mean, um, you know, what's on the inside. Now, both of them had a pretty good viscosity rating to it, but you can see the Valvoline chose not to use any moly, and they had a sufficient amount of zinc, um, about the same amount of calcium, and in there. So the label really doesn't tell you what's going on. Now here's wear metals. You're going to see iron, copper, aluminum, lead. We got to say something in here for extreme duties of what's in there. So just consult with your engineer or your the person I always like to talk to is the lab person in the lab that actually did it. They'll help you explain what's going on because they see these analysis all the time. But one of the cautions in the racing world is if it has a high amount of lead, because there's not that much lead in the metals in a race engine, it's probably from the fuel. Okay, so that's going to show you what's going on with the fuel. So just watch out on the caution on that if you're running leaded racing fuel. Now, you're going to have molybdenum, which is your moly. It's always good to have a little bit of moly. Most people have got 0 to 100. Companies that state they use moly, normally about 400 is a good amount. Anything more than that is kind of an overkill. You've got your zinc phosphorus, which is in there, and which acts as kind of like your anti-wear in your buffer zone. In your modern API certification levels, now it's only down to like 500 parts per million. Back in the day it was maybe 1200. Usually to have a good cam protection, you need at least 1500 parts per million. When you start getting into extreme duties past 1500, you really need to use synthetic and other alternatives to zinc, because if you have too much uh, zinc in the oil, it will get into the combustion chamber and it will cause detonation as it really starts screwing up the spark plugs. I don't know why, but I mean, It really does. So it really affects the combustion chamber cleanliness. So just consult your lab and your engineers on that. Another thing is oxidation, which means a thermal decomposition of the oil. Oil oxidation is really important. I see one of the reasons we want to try to keep the oil cool is if you could lower your oil temperature about 18 degrees, you'll greatly increase the life of the oil in the additive packages. All right. But oil oxidation means breakdown, and what that means is that the oxidation thickens the oil, forms harmful deposits, which can become acidic and corrode and hinder the moving parts. Usually, excessive levels of oxidation are found because of overheating, overworking, extending the oil drain interval, and fuel. This happens in racing when they go to that fourth race on the oil change when they should have changed to three, right? So all I can say is you spin out the oil filter and give it a smell, and if it smells like racing fuel, you better dump it. So there you go. We've got calcium, magnesium, sodium, which is for your detergency package. Now, one of the things we have to remember, less detergency isn't better in a racing oil, and too much isn't good. You have to have a happy medium of about 1,500 parts per million. That's what we do in the SynMax products. Now, other people have their other theories. Some people have the theory that if you cut back on the detergency, then it allows the moly and the other additives to slicken up the engine more to reduce friction. But the problem is then it creates a very dirty environment because you don't have enough. Yet if you have too much detergent in there, it washes everything away and it has an opposite effect. So just consult your engineers and your lab people on what you feel is best to the application. Look for antifreeze in water, in case something's leaking. We talked about fuel dilution. Do not let that happen. All right. Silicone, as I said, silicone is a tricky one because so much silicone is in the oil and it's required for the anti-foam package. Unfortunately, if dirt and dust and contaminants get sucked in the oil, it's going to maybe throw a red flag on the oil analysis report, and that'll affect your anti-foam package. So just watch out. Here's a basic viscosity chart. You'll see that you have ISO and SAE grades. For instance, an ISO 22 Industrial Standard Organization ISO 220 is the same thing as a 90-weight gear lube. All right, and at the same way, in a crankcase motor oil, it's like the same thing as a 50 weight. And if you go a little bit lower, an ISO 100 is equal to a 30 weight motor oil, and it's also equal to like a 80 weight gear lube. So it depends on. It's not exact, but it's kind of a general science I'm talking about. So just educate yourself and talk to your lab and oil engineer technicians what's best for you. Here's that chart a little bit bigger. Uh, and as I said, I know I'm going through this very quickly. Just hold the slide wherever you're at, and if you want to, stop it and study it. But what we have to understand is we have what's called synergy and stability. You've got your base oils, which is between your metal parts. Here we've got a sliding on top and then friction on the bottom. And then you can have, let's say, a surface technology such as moly that's used by Schaefer's, Royal Purple, and Joe Gibbs. Or else you got diamond-like additives, which are from SynMax Performance Lubricants with their aerospace advantage. Whatever they do, okay? Then you have your anti-wear package, which is in the red. So everything has to work in coordination with each other for the advantage you're looking for. And as you can see, you just have the regular oil with not that much additives on the left, or you can have all the elements working together uh, because actually with oil and molecules really quick, you've got two types of friction. The molecules, having friction within themselves, within the oil, and then the friction the oil molecules has against the surface. Yeah, I bet you didn't know that one. So everything has to work in concert and symphony. And if you don't like the oil that you bought, don't be throwing other things in it. Okay, just buy it better oil with all the additive packaging. Right? Just think about that one. So again, here's some old oil analysis that we had. Here we got Joe Gibbs 20 weight, and you can see that the moly was up there, about 1,000 parts per million, and and that's how they decided to do their program. Calcium sulfonate phosphorus, unfortunately, was just at 1,000. Should have been like at 12 or 1,500 for racing, but that's how they chose to do it. Yet here we have a Valvoline racing oil, like we shared before. Valvoline has almost no moly, at about 1,300% on zinc, and yet we had Joe Gibbs, another 10 weight, 1030 oil, but they had 1,000 or more parts per million of moly. So it's all in what you're choosing. Know what it is. Don't buy the label. Educate yourself. Here was the Joe Gibbs synthetic blend. The moly was 800, yet the phosphorus was at 700. I don't know why. Here we had a Schaefer's. Okay, their moly was pretty good. About four or 500. Their zinc was at 1900, and but they had like a heavy duty truck detergency package at like 2400. So that was the different theories between those two products. Here was Valvoline VR1 racing oil. The moly was 0. Okay, and yet the Joe Gibbs here, they had for their 1550, um, they had XP6, they had like about 500 parts per million of moly, yet they had 1400 on the zinc. All right. Here's Pennzoil. Here's a pretty good product. Had about 100 parts per moly, which is about what your Mobil 1 synthetic runs. The zinc phosphorus, they were really heavy on this one, 2,300. They wanted it to work in a lot of detergency package. So I don't know if they still have this formulation, but they had that back in 2006. And here was some Brad Penn. This is the one that kind of put me to the side. You know, uh, no moly, not that much zinc, but a pretty good detergency package. So that's the theory that they used when they put their oil together. So as I said, we weren't coming against anybody on anything on any engine or oil companies. What we were trying to say is you need to educate yourself. If you want to know what's in oil, spend $10 or $15, get an oil sample. You need to get an oil sample when it's brand new and then after it's been used, and then compare the two together. All right, and because sometimes what it says on the label isn't true. So what's inside the bottle is the truth. So we just wanted to do this so that you could think to study. Anyway, uh, this is Clayton Balmas here with SynMax University at synmaxperformancelubricants.com. We wanted to thank you for our time together, and I encourage you to look at our other presentations we have for education, and we'll see you at our next session. So bless you, and goodbye, and we'll see you again.